F11. Yes, finally. Okay, thanks. Thanks for joining to the talk called Newcomers Experiences. Why do we need a stricter Julia mode? My name is Jorge Vieyra. So who am I? So I'm a chemical engineer. As I already said, my name is Jorge Vieyra. And I have some experiences as a chemical engineer because I had to learn Pascal and Delphi during bachelor's, and then I also had to learn Fortran 77 and Python. These are not things that I wanted to learn. It's things that my teachers asked me to learn because reasons. And then I learned about those because I had to teach Physics 101 as a TA using Python 1.6. And then I also had to, I learned Perl because we had to process some data for some molecular simulations. And then, of course, I had to learn C because real Linuxers used C. And then, of course, I had to make some money, so I learned PHP and MySQL. And then I had to use MATLAB for chemical engineering process simulations. And then, of course, I have to use C again, but now for real, for computational fluid dynamics at MIT. And of course, I was a teaching assistant at MIT for using MATLAB, and then I had to use Math and Python and XML. Now Julia. So that's what the chemical engineers needs to learn nowadays, I guess. Or maybe not anymore. But that gives me maybe some perspective on things about programming languages, especially if people want to learn a new one. So I work at ASML, but I also have some other friends that are also trying to learn Julia, and I see them struggling a bit. So what gives? So let's see. Oh, that's the timer for the previous talk. Whatever. It will keep beeping. Put it there. Okay, it's okay. Sorry about that. Then what is this presentation about? So I have seen some friends and colleagues struggling while learning Julia. Many only know MATLAB or Python, or sometimes they claim to know C. What is this? Yes, I don't know what's going on there. So depending on the starting point, they struggle or not. So that's really, really annoying. So perhaps a strict mode will help. So I'm going to give you some examples about things that I have seen people struggling with, and we'll see if we can have a strict mode. However, a couple of weeks ago, oops, what did I do? A couple of weeks ago, I saw this post by Keno. Say, oh yes, we want to have opt-in for a strict mode. So apparently they're already looking for a strict mode. So I think we're done here, right? Well, okay, maybe not. Maybe we should talk about more about that. So what I've seen, people coming from Python, what happens? So people coming from Python, they do usually this thing. They just start an array, because why not? A list. So that's the first line number 3. And then they just push items, whatever. Now, this is a very simple example. This is a cartoon example. And then they just want to have a sum, and then, oh, this is so slow. I thought that Julia was fast. Yeah, well, what's the problem over here? Any takers? Yes? Yes, you're creating other allocations. Anything else? Yeah, the L type is any, exactly. So that's the problem. These 2 lines are the problem. So L type is any, and you're creating allocations. So how do we fix this? Well, there are several ways to fix that in Julia. You create, you change the L types to int in this case, or you can pre-allocate your vector, or you can use list comprehensions, or you use functional style. There are several ways depending on your case, but people need to know about this. So if someone will tell me, yes, don't use any type. Oh, yes, please don't allocate all the time. That will be a nice thing to have. So what's the next thing that I have seen? Okay, I also have seen people coming from NumPy. Remember, NumPy is not Python. So everything that's fast in Python is not Python. So NumPy, thank you, Keith. So, so from NumPy, this is actually a cartoon example of a problem that a colleague sent me. He was shouting like, oh yeah, Julia was supposed to be a fast language. Are you sure it's that? Does it have problem with complex numbers and whatnot? And I don't know what he was doing exactly. He was doing some sort of a convolution with an image. It doesn't really matter, but this is what the essence of his code had. So I don't know if you can see the font size. I put it as large as I could. Oh, the reflection. Okay, so basically, he had some image, so he started an empty array with complex zeros. This is the kind of the code that he used. And then he had another larger image, and somehow he can calculate some kernels and convolutions. That the details are not important. But what happened eventually was that he was just accumulating over the image in a certain way, calculating the centers and adding them up. Again, the details are not important. So, and then he benchmarked it, and then in Julia, these are his numbers. So in Julia took, these are the wrong numbers. These are, oh no, yes, in Julia it took 65 milliseconds for 100 size image, and 800 milliseconds, where Python took 280 and 28. So it was like, okay, are you sure? Does Julia have problems with complex numbers? So what's the problem with this code? Looks perfectly fine to me. So what's the problem? Integers? Yes? Slices. Yes. Something else? Someone else? Okay. Also, we have an abstract type over there. Complex is not a concrete type. So this was one of the problems, one of the two. So one is complex is an abstract type. Again, we have problems with L types. So that's one of the problems. The other problem is, yes, slices. Over there, when you slice in Julia, you make a copy. In NumPy, it's a view by default. But in Julia, because it's more explicit than Python, instead of Python, you don't have that. You have that. Moreover, you're also allocated on the, you're not assigning on the image directly. So what's the solution for that? Okay, first, use a concrete L type, in complex over there, and also use a view, and also use the dot operator for accumulating, and that's actually faster. So when you did this, then now it happens that Julia is way faster than Python in all the cases. And then he was happy to say, yeah, how am I supposed to know this? I mean, I just wrote my code, I just copy-pasted from Python, and it was supposed to be fast. And I partially agree with him. Like, there's nowhere that Julia tells you, oh, you're doing this wrong, or it's slow. So, and then people get disappointed, and that's kind of one of the problems that we have. One last example, and I promise this is the last one. So, any takers? What's the problem with this sum? Yes? Yes, exactly. So, right now, total is initialized. So I was told in school that you should always initialize your variables. Yes, it's initialized at 0. Yeah, people in MATLAB just write 0 because, yeah, what else you will do? And then when you try to accumulate, yeah, and then it's low. And that changes type. It's changed from int to float in this case. We didn't put it in this case, but v was a float. And that changes. So that's one of the problems. And you can quickly see the difference. One takes milliseconds, the other one takes microseconds. So, but these are things that Julia doesn't tell you anything about. So what I argue is that for the examples that we already have 5 things in 5 simple common mistakes that everybody does coming from Python, NumPy, or MATLAB. And there's nothing that's guarding that. So we have this implicit any with the array type. We have slices that makes copies. We have abstract L types, growing arrays that makes a lot of allocation, and changing variables. I think that we could have some warning for this. I will argue that. So how can we fix this? Well, first, one small interlude. Why do people like Rust? I don't know if Miguel is in the audience. No. Why do people like Rust? The compiler. But it's not only the compiler, because you can also compile things with C, and then they go with Rust. Why? Any takers? Well, I will argue, maybe this is not exactly true, but I will argue because it front loads possible problems. Rust compiler is famously very shouts at you all the time. So if you're masochistic, you work with Rust, but it tells you everything that will go wrong up front. And that's why developers like it. They don't want to have problems at runtime. They want to have problems at compile time. So maybe we can have something similar in Julia, not like Rust maybe, but similar. And then we can have 2 modes. People can keep using the same thing as usual, like the REPL or in notebooks with Pluto or VS Code or whatnot. That's fine if they have these niceties because it makes them easier to transition from Julia to, so from the things to Julia, so Python, MATLAB, whatever. But if we're working with modules, I will argue, yeah, and now I want to squeeze every single ounce of performance that I can. So maybe you should have some performance mode, or strict mode as I call it, that while writing modules. Also, maybe we have some other niceties that can help the developer while writing modules. So there are some of my suggestions. So again, there was this nice issue that was opened 2 weeks ago. I think also Lily is contributing to that. Thanks. So what are my suggestions for strict mode? Well, first, disallow implicit any. Please, please, if you have that, you should, in my opinion, you should just error. Like, no, you should not allow that. Or explicitly allow it. Like, have some pragma or something over there, a comment, like maybe MATLAB style, where you allow it, say, okay, disallow this, now allow it in this particular case. Also warn where you have slice and copies. Yeah, maybe people want that, but more often than not, people are expecting a slice. So you say, okay, just let me know when I'm making a copy. It will be annoying, but at least I will know. Warn about using abstract L types. Sometimes I have to use abstract L types, but in general, if I have it, most likely that's not what I want. Also warn about growing arrays, MATLAB style. MATLAB has this very nice, I would say, light on this nice box on the top. It's yellow or green or red. Red one is completely wrong. Orange when you have some allocation problems or performance problems, and green when everything is good according to MathWorks. Maybe you have something like that in the linter, or maybe even the compiler can tell you, or mix and match. So I'm just saying. Also warn or error if you change a variable. So if you use code warn type, you will see that, okay, your variable changed from int. Is that your type of your variable is union of int and float or whatever. Maybe you just warn it, okay, this type, it happens to be a union of two types. Probably that's not what you want. So just have a warning over there. And then some other things that I didn't talk about, so I would just drop all of them over here. So sometimes some colleagues, like Tom here, likes to annotate the hell out of all the functions, which I find it very nice, because then I know what the input and output for many functions, not everything. This is so nice sometimes, but then it's very easy to see, okay, my function, okay, the input is an abstract vector. Okay, I know that V is an abstract vector. Okay, good. So something that tells you, okay, you forgot to annotate your inputs and return values, or return types. So with that, maybe have a GC allocation threshold. Say, okay, you're allocating too much. Maybe you can reuse your memory somehow. I don't know. Another pattern that I see some colleagues doing, this comes from Python. They just check the types inside of a function. So instead of using multiple dispatch, they check, okay, if my something is list, or in this case an array or a vector or a matrix, do this. And they have if-then statements in their code, which sometimes is necessary, but more often than not, you want to use multiple dispatch. You don't want to use if-then. So I will say, okay, maybe you have a warning if you see that pattern over there. Maybe the linter can tell you that. And I don't know, somehow some type inference warnings. I don't know how to do this. This is just visual thinking maybe. But maybe we want to have something like that. So those are my suggestions for strict mode. Maybe you have your own. So I saw that there's this issue. Maybe you should start posting your own suggestions over there, because I think they're looking for input on that regard. And I think that if we had had that, maybe this talk will not have had any, well, Michael here will have had some help toward what he called the 1.5 language problem, because some of the problems that he had were exactly, oh, there's an error over there. He had problems reallocating with the slices, with views, with changing types, precisely because he didn't have any guardrails. He just copied his MATLAB code and then like, it's slow. What do I do now? And the documentation was helping. I'm expected to read a gazillion posts and docs here and there, and it's a bit hard. So maybe with that, Michael here, his talk is tomorrow. Follow up on this. We'll have a better chance with Julia. And one more thing. This is almost the very last slide that I have. So this is in order to have a composable code in Julia, you have to program in a particular way. If you don't do it in that particular way, then your code is not that reusable. And if you program like Python or MATLAB in Julia, code is not really that reusable. And I will say this is a small snippet that Yuri, one colleague of mine, made. And it kind of, I think, is a minimum example of code that you should have in Julia that tells you, okay, I have an abstract type, and I group a lot of structs based on that abstract type. I have an overarching function, this calculate thing, that is expected to have a very specific function that works for each concrete type. And that's kind of the template for many reusable code, arguably. However, there's nothing in Julia that ensures that my abstract, that my A structure and my B structure over here actually have a thingy implemented. There's nothing. So I don't know where to put this, but I want to throw it out there because it's one of my pet peeves with Julia. So in summary, maybe a compiler should facilitate some learning, not only just complaining about things, but facilitate some learning, especially when you want to have more performant code. If you front load your issues, if the compiler complains, it shouts at you, you can fix the problem up front instead of running your code and then realizing, oh, it's slow. Okay, what do I do now to speed it up? So if you front load the problems, it's easier to speed things up. And then if you have this opt-in strict mode, I think it's a great step forward. Please do that. I don't know exactly how you're going to do that, but thanks. And that's it. So if you have any questions, please, now's your time. I don't know who's next. Questions? No questions? Super clear? Super ranty? Question. Okay, where's the microphone? Yes. Next speaker maybe should start preparing his presentation. I don't know who's the next speaker. There's the next speaker? Come.
Yeah, thank you. All right, thank you for the presentation.
Sure, thanks.
So I just had one comment about your previous slide about the one thingy.
Yes?
Because it's actually something I also run into. What I usually do is you define thingy for just abstract thing, and then it throws an error.
Yes.
But
that's a way to deal with it. I agree.
Yeah. What do you see are the problems with that?
Well, first you have to implement it. So if you don't implement it, that's a problem over there. So maybe you want to use that thingy with a generic implementation, but sometimes you say, no, I don't know what it will be. You can throw an error. But I would like it to say, okay, thingy is just one function, but what if you have 10 of them? I want something to tell me, okay, if you want it to be an abstract thing, you have to implement method 1, 2, 3, and maybe 5, or one of the last two. But right now, I have to actually know. I have to see the code. And sometimes it's not in the same place. Right now, it's very condensed, everything in the same place. But sometimes things are spread all over. Case in point, abstract string or abstract vector. And you only see the errors way down the line. Yes.
Yeah. All right. Yeah, I definitely agree. Thank you.
Yes. Question? I think you should start.
I'm not sure that I quite understand the last example. It seems to me that you could put curly braces around the struct declaration and then declare some sort of type, but I confess that I don't understand the example. So my real question is, Julia already provides these tools like the macros for @code warn type, which tells you if you have some sort of mixing of types that happens inside of some function. And it also tells you how many allocations there are. I would say that the more accurate thing, and I agree that this is a bit of disinformation that goes out about Julia, is it's not your code will automatically be faster. Julia says you can implement it very quickly, and then if you know what you're doing, you can make it as fast as some lower level language. Is your solution here something that would be in addition to @code warn type for this macro and for allocations? What are you adding on? What's the suggestion?
Yes.
Exactly.
Is this on? This is not on. press button. Don't touch it. Hello? Yes. So yes, it will be an addition to that. The thing is that add code one type works. It's perfect. I love it. It's my favorite tool. But for when people just coming from all different languages, they don't know about this. And then the syntax, well, it's, I mean, the errors, the messages are easy to read at some point, but you have to get used to that. So this is just for newcomers, for getting started. Just it's an extra aid for developers. Of course, this is just maybe the tip of the iceberg. If you want to go deeper, you have to use code that one tab. You have to use Jet, Cthulhu, Snoop compile, all the usual suspects. But if you have these very simple, low-hanging fruits, you can solve maybe, I argue, maybe, I don't know, 50% of the problems without actually having to use those tools. I don't know how are we doing on time? Yes. Plenty of time. What time is it? Did I talk too fast? Oh, okay. Ooh, I talked too fast.
Thanks for your presentation. I've one question about the learning trajectory of newcomers to Julia.
Yeah.
So in your company, how did you address all these common knowledge gaps with newcomers?
That's an excellent question. My company, we're suffering that because, yeah, documentation is all over the place. And the way we deal with that for now is just with trainings. So we give some trainings and teach people you have to do it like that. We have some forums so people can ask some questions. But I agree, it's complicated, especially if you only depend on documentation. That's why I think that if a compiler can help you to learn, that's what people, again, another thing why people like Rust is because Rust complains a lot and tells you, okay, you are doing this thing in the wrong way, maybe you should do it in this way, it's better. Or you're doing it bad because of this, you should do it this way. If we can have those kind of error messages, that will help us to develop faster. Plus, it will also teach us how to program better.